Good morning all. So today we will discuss about RLC circuit. Now if we start with RLC circuit, then we will think about the meaning of RLC circuit. First of all, now R stands for resistance, L stands for inductance, and C stands for capacitance. Now all these parameters are the properties of some component or electrical or electronic elements. Now if we want to visualize the resistance, inductance or capacitance, then we will not be able to visualize, because these are the properties produced by some materialistic component. So what are those materialistic component? So resistance is the property of resistors. So resistors will develop some resistance. Inductors will develop some inductance, and capacitor will develop the capacitance as their properties. So these are the properties and these are the components or elements. We have the materialistic existence for those three components. Now if we want to study RLC circuit, then we need to make the RLC circuit. Now how to make the RLC circuit? So now if we go for making the RLC circuit, we definitely will be able to do it in many ways. First of all, in series, in parallel, or combination of those. So parallel circuits, series circuit. Or the combinations. Now in case of series RLC circuit, what we can remember or we can think is something like that. So there will be three components connected in series. So in case of series, the current remain constant, as we have already understood. In series circuit or series connection, current remain constant, and in case of parallel, the voltage remains constant. So we have already come across this type of circuits, series circuits or series connection, and parallel circuit or parallel connection. Now if we want to make this type of circuit, so definitely we will not get any such type of symbols in our laboratory. We will have some circuit boards like breadboards or PCBs. So there we need to connect this type of elements. So as in case of practical or practical experimental bench, we have some materialistic connection board. So definitely we will need the materialistic component. So for resistance R, for inductance L, and for capacitance C, definitely there will be the components available in the laboratory. So if you go to the laboratory workbench, for resistor we will find this type of devices or components or elements. Say there will be some capsule like thing with two leads, and there will be several bands, and these bands are made with different colors, and this is called color codes. And using a certain protocol, that is the color bands will have several types of values, and there will be a particular protocol how to calculate that the resistance of that. We will get its properties, that is R. So device is resistor and the property is R. Symbol is this type of zigzag pattern. Now for inductor, definitely we will have some other kind of device or component. So for inductor we can get some inductor in this form, that is look like a bobbin, and there will be some windings, copper, generally made up of copper windings will be there. So it looks like the bobbin whatever we generally use to fly a kite with the help of cotton thread. So similar type of the turns or threads will be there. So this will not be cotton thread, it will be made up of metallic wire, so that current can be flowing through this type of conductors. So this type of the turns of winding will create some inductance, and the symbol is this type of loops continuously made, either 3-4 loops will be there, and symbol of the parameter or symbol of the property is given by capital L. So this is inductance, and this inductance can be calculated as we can remember that L for single layer solenoid will be N square mu A by L, where L is the length of the solenoid, A is the area of the loop, N is the number of turns, and mu is the permeability of the medium. So we can get certain value of L if we put certain number of turns, certain amount of area is given for the loop, and permeability will be the material property of the domain, and L is the length of the solenoid or coil. So L will be fixed from this materialistic device. So we will get that type of terminals also. So this is also two terminal device or component. Resistor is also two terminal device component. Now what about for the capacitor? Now for capacitor we will find either ceramic type or paper capacitors, which will be looking like one button, and there will be some number like 104 or something else, which will be also utilized for calculating the value of capacitance, and there will be the leads. Now some capacitors are also found as a cylindrical shape, and it will have also two leads, and those two leads will have different lengths, and generally the longer length is nothing but the positive terminal and shorter length is the negative terminal. So this type of capacitors looking like the cylinder is called polarized capacitor or electrolytic capacitor. Here also will be some voltage and the capacitance values like say 47 microfarad or something else. So or even 1 microfarad, 10 microfarad, anything will be written as per the manufacturer say indication. So in this way we will be able to get some capacitors. And now if somebody has cut this type of legs somewhere during the connections, there will be no difference between the lengths. So during that time, during the situation, we will also find some band, and that band will have some arrows, and those arrows will be near the negative terminal. So you have to look for the band with arrows which will indicate us the negative terminal, other one will be positive. So this type of some protocols are there. We have to maintain, we have to know first, and then we will be able to maintain those things to connect in a proper way. So for DC circuit, polarities are fixed, so we can use the electrolytic capacitors, but in case of AC circuit, we can use the paper capacitor or ceramic capacitor, the non-polarized capacitor. So now in real case, how to make the series RLC circuit? So definitely we will have some resistors like this. So we will be taking, let us consider that the legs are bent, otherwise we will not be able to put them in the breadboard. So there will be bands like that. So two terminals will be put in two holes, and also there will be the bobbin like things, and there will be the copper windings, and those windings will be also having two terminals. So this is the inductor, so it will have some inductance, it will have some resistance. And for capacitor, there will be this type of devices. This will have also two terminals. There will be some numbers like 104 or something else. And then what we have to do? We have to do, that is connection here. You can see that starting point of resistor and ending point of resistor. And ending point of resistor is connected to the starting point of inductor, and also ending point of the inductor is connected to the starting point of the capacitor, and ending point of the capacitor are available. Starting point of the resistor is also available. Now these two terminals are connected to the source. We are giving AC source to study the AC response. We can connect like this. So similarly in the laboratory, we have to take the connection from the starting point of resistor and ending point of the capacitor. So we will be connecting these two with the supply, AC supply. This will be a voltage source, and then ending point of resistor will be connected to the starting point of inductor. Ending point of the inductor will be connected to the starting point of the capacitor. So in this way, we can see that if this can be taken as the instantaneous polarity, we can see that current will be conducting in this direction. Okay. So current will be same. So IR and IL, this is the IL, and this will be IC. So IR will be equal to IL will be equal to IC equal to say I. So this is the current. So whenever we will go for developing the RLC circuit in practical field or in laboratory, we need to collect the practical component for R, L and C. So here whatever is written on the paper, that is the symbol and the alphabet for representing the symbol of resistance. Here similarly L is representing the inductance and C is representing the capacitance. In practical case, we need to collect the components, practical components, that is resistor, inductor and capacitor. So those components also may be looking like some other type, but here I have taken some examples. Now the resistor will have two leads, we can see, and inductor also has two leads, two connecting points. Capacitor also has two leads, and all these leads are required to be connected as per our requirement. Means if we want to connect them to develop a series RLC circuit, so the starting point of resistor and the ending point of the capacitor will be connected to the supply, and ending point of resistors will be connected to the starting point of the inductor. Ending point of the inductor will be connected to the starting point of the capacitor, and as we told that the ending point of the capacitor will be connected to the supply. So as in our drawing we have seen that the starting point of resistor is required to be connected to the supply, as well as the ending point of the capacitor is required to be supply. So definitely we need to connect one supply at this point and at this point, and after that we need to be sure that these 2 points are connected, electrically connected, and these 2 points are also electrically connected. Then only our series RLC circuit development in practical field will be completed. So this will be the connection procedure of one series RLC circuit. Now in the next class we will understand how to study the AC response of series RLC circuit. Thank you.